comes to multiplying numbers that are in scientific notation, what you're going to do is you are going to multiply these numbers out front, and then with the exponents you're going to add the powers. So 3.5 times 4 makes 14, times 10 to the, add the 11 and 23 together to get 34. But that cannot be your answer in scientific notation because 14 is not allowed. You have to have one digit to the left of the decimal. This needs to be a 1.4 times 10 to the something. Now, in figuring out what this power is, we've really divided by 10 to go from 14 to 1.4. We made this smaller. So if we divided by 10, we actually have to multiply in by another 10, making this one larger at the right, and so that 34 is going to turn into a 35. And that now is in scientific notation as opposed to the line above. In number 7 here, we're going to multiply these numbers in front, and it turns out that 2.45 times 3.5 is 8.575, and then we're going to add these exponents, 17 and 12, add together to be 19. Now that is your answer as far as us math teachers are concerned. However, I just want to make a comment here that your chemistry teachers may not like this answer. When you get involved with what they call significant digits, you can't have an answer that's more precise than the two numbers you use to multiply together. Notice how we have 3 digits to the right of this decimal, which has this rounded to the nearest tenths, hundredths, thousandths. But the two things that we multiply together were rounded to the hundredths and to the tenths. The one that's rounded to the tenths is the least precise, and so we want our answer to match the least precise thing we multiplied by. So your chemistry teachers would probably want this rounded to the nearest tenth and would prefer you write 8.6 times 10 to the 19th. But we're going to leave our answer just as we have here for this problem because we're not in the chemistry class. When it comes to division, we're going to do exactly the opposite of what we did a moment ago. We're going to be dividing these numbers out in front, and we're going to be subtracting the exponents. Now 12.5 divided by 2.5 turns out to be 5. I'm going to write it as 5.0 times 10 to the, subtract, negative 4, take away 19 is negative 23. Now this is allowed. We are allowed to have negative exponents with scientific notation, but outside of scientific notation we're not allowed to have negative exponents in our answers. For problem number 9 here, without breaking out a calculator, do you notice how 2.4 is half of the 4.8? When you divide those you get a half, or 0.5, times 10 to the, well, we've got 8 and 42. We subtract 8 minus 42 makes this negative 34. But this answer is not in scientific notation because we have a 0 to the left of our decimal. I'm going to convert that into 5.0 times 10 to some power. Now on the left, going from 0.5 to 5.0, this got larger, so to compensate I'm going to make sure that this gets smaller and divide one of those 10s off. And the next integer smaller than negative 34 is negative 35, not negative 33. Remember how in the negative numbers, smaller actually means a larger negative number, so to speak.